Alright, I thought it'd be nice to do some additional examples for section 6.1. So here are some that I pulled directly from the textbook. So what we're asked to do is that we're asked to graph the velocity function over the given interval, then determine when the motion is positive or negative. Then we're asked to find the displacement over the given interval. Then we're asked to find the distance traveled over the given interval. So for this one, we're going to be looking at 10 sine of 2t on the interval from 0 to 2 pi. So the first thing I'm going to do is I'm going to graph this. You can do that using your graphing calculator. I like to use a website called Desmos. So I'm going to go ahead and pull that up over here for us. If I can figure it out, which I totally can. Let's see. Have that. Bring it over. There we go. All right. So here is the website, Desmos. So desmos.com/calculator. I'm just going to type in the function we were given. So y equals 10 sine of 2x. Now, this isn't exactly what I would like. I would like a little bit of a cleaner graph. So I'm going to go up here to this little wrench, and that's going to change my settings. So my x, or my independent variable, I want that to go between 0 and 2 pi. And let's go ahead and make it in steps of pi over 2. Okay. And for my y-axis, well, since I have an amplitude of 10, let's go ahead and go between, negative 12 and positive 12. Great, that gives me a much cleaner graph. Now remember, I'm going to have a positive displacement whenever I'm looking at area above the x-axis, and negative whenever I'm looking at area below. So I'm just going to go ahead and move this off for just a second. And if I want to find the displacement over the given interval, what I'm going to do is that I'm just going to take the good old integral of this function. So for part B, to find the displacement, that's just the derivative from 0 to 2 pi of 10 sine of 2t dt. Alright, now to solve this, remember I have to use something very special, which is the u substitution method. So let u equal 2t, which means du is going to equal 2 dt, which means that 1/2 du equals my dt. Okay? Remember, when I'm doing u substitution, I can also change my bounds. So this is going to become from 0 to, and if I plug in 2 pi for t here, my upper bound is going to be 4 pi. So that's going to be 10 sine of u du, and don't forget I have that 1/2. So that's going to give me the integral from 0 to 4 pi, 5 sine of u du, which is going to give me, let's see, so 0 to 4 pi, 5 sine of u, so what's the antiderivative of this? It's going to be negative cosine of u. I need to evaluate that. Oh, oops. Get the 5 out front. From 0 to 4 pi. And I will get that equals 0. I could have also known that this equals 0 because, let me go ahead and pull this graph back onto our screen. Because if I look at my function, well, this is symmetric over the x-axis, so that means I'm going to have just as much positive area as I am going to have negative area here. Same here. Same amount of positive area as negative area, so they're going to equal 0. However, it's not always a bad idea to flex our calculus muscles and do some work. Great, so now that that's out of the way, so this was part B, let's go ahead and let's do part C. So what that's asking us to do is it's asking us to find the distance traveled. So total distance, remember, we can think of that as gross displacement. So that is going to be the same as the gross displacement. That means that when we're looking at solving for C, we're going to have to look at the integral from 0 2 pi of not just this function, but we want the absolute value of this function because we want our negative displacement to also count as our distance traveled. So what we need to do in order to solve this is we need to figure out, well, where is our function positive and where does it have negative displacement? Because remember, we want that negative displacement to become positive. So what I could do is I could break this up into 1, 2, 3, 4 intervals, or what I could also do is I could notice that all of these have the same area. They're just flipped. So how many of these areas do I have? Well, I have 1, 2, 3, 4 of those areas. So really, I just need to find the area from 0 to pi over 2 of this function and multiply it by 4. Let's get this out of our way. So what this is going to be is that's going to be the same thing as taking 4 of those areas from 0 to pi over 2 of 10 sine of 2t dt. That's going to be the same thing. So let's go ahead and evaluate that. So again, I'm going to use u substitution. So I'm going to let u equal to t, which means that I'm going to have 1/2 dt equal to, oh, whoops, sorry, that should be a du there. So that's going to be 1/2 du equal to dt. So let's see, if I plug 1/2 in for my dt, 1/2 du, that'll become 5 du, and that'll become 20. 20. And then this will still be 0. If I plug pi over 2 in for t here, my new upper bound would be, well, that would just be 5. And this would be sine of u, du, which would be negative 20 cosine of u. We need to evaluate that from 0 to pi. So that would be negative 20 cosine of pi minus negative 20 cosine of 0. So let's see, cosine of pi, that's negative 1. So negative 1 times negative 20 is negative positive 20. Cosine of 0 is positive 1. So that would be negative 20 minus, so that would be positive 20. So the answer we should get is 40. Awesome. Great. So let's look at doing another example, only this time we're going to change our function. Alright, so now what we're going to do is that we are going to look at doing the exact same thing, only now we're going to look at the function v of t equals t to the third minus 4t squared plus 6t. So again, the first step is I want to graph this and figure out where it's positive and negative. So I'm just going to go ahead and pull that awesome graphing utility Decimus back over here. Okay, great. And we are going to graph this time t to the third minus 5t squared plus 6t. Now, I really don't want these to be the same as last time, so what I'm going to do is I'm going to change my x-axis. I want that to go from 0 to 5, and let's do steps of 1. And for my y-axis, let's go from negative 2 to, I don't know, let's try 20 and see if that gives us something like almost. I can see that this is going to continue to go up, so that's pretty good. We can make it a little bit taller, so let's do 40. There we go, that's beautiful. So what I can see is that I'm going to have positive area between 0 to 2, and then I'm going to dip down into some negative area before I dip back up into positive area from 3 to 5. So I'm just going to draw a little graph over here to kind of help myself remember what that looks like. So I don't have to keep bouncing back and forth in between. So, beautiful. it's going to go up, down, and then it's going to go up. And it changes between 2 and 3, and we're looking all the way to 5. Here's 0. All right, great. So first, to find the displacement over the given interval, well, displacement, that's just the regular old integral of our function. So we're not doing anything fancy when we're doing net displacement. Okay. So plus 16 dt. So that's going to equal t to the 4th divided by 4 minus 5t to the 3rd divided by 3 plus, well, if I take t to the 2nd divided by 2, that 6 is going to become a 3t squared. Need to evaluate that from 0 to 5. Alright, now, if I actually plug 5 into this, what I'm going to get is 5 to the 4th over 4 minus 5 times 5 to the 3rd over 3 plus 3 times 5 squared. All of that minus, well, if I plug 0 in for t here, I'm going to get 0 over 4 minus 0 over 3 plus 3 times 0, so that's just going to be 0. And my final answer will be, so after I plug all of that in, what my final answer will be is it will be 275 over 12, which, if you want to get the decimal approximation, is about 22.92. Great, so that's it for finding the net displacement. The next thing that we're going to do is we're going to try to find the distance. We can also think of that as our gross displacement. So let's get rid of that, and we will start work on part C. Remember, part A was just graphing, so we're already done with that. So I really don't have to erase all that much because the difference between finding just the displacement and the total distance, or the net, is that instead of just taking the integral from 0 to 5 of this function, I need the absolute value of this function. So I need the absolute value, t to the 3rd minus 5t squared plus 6t dt. So that's the absolute value of this function. Now remember, when we're doing the absolute value, what that means is that anything that's below the x-axis is actually going to get flipped above. So this little bit, I'm going to get flipped above. So the absolute value function, this guy, would actually look like this. And then this part would get flipped up, and this would, whoops, well, you know, it would continue to look like it does, like that. So what we need to do is that we need to break this up into the positive and the negative. So what this is going to be is this is going to be the interval from 0 to 2, because that's where I have positive, t to the 3rd minus 5t squared plus 6t dt. And what I want to do is I want to add to that, not the area from 2 to 3, but the positive area from 2 to 3. So how do I take the area from 2 to 3 of this function and make that negative area positive? Well, remember, if we have a negative and we want to make it a positive, what we need to do is that we need to multiply it by a negative. So instead of adding here, what we're going to do is we're going to subtract, because that subtraction is going to make that negative area positive. So this negative area is going to become positive, and then we want to add to that positive area from 3 to 5 of our function, t to the 3rd minus 5t squared plus 6t dt. Okay, great. So when we do that, and we evaluate each of these pieces, what we are going to get is about 23.75 is what we are going to get if we evaluate this correctly. So remember, the reason that we're subtracting this right here, we're subtracting this because this is negative area. So if we have a negative times negative area, we're going to get is we are going to get positive area. So the key here is always remember to subtract that negative area.